Friends, let's find electric field due to uniformly charged spherical shell. Let us have a spherical shell. This is a spherical shell of radius capital R. Let us place uniformly charged Q on the surface. Now there are three cases. Case number first, we are going to find electric field inside the shell. So electric field inside the shell, charged shell. So you know that according to Gauss's law, flux phi is equals to close integration E dot ds, which is equals to q upon epsilon naught. So if you imagine here a Gaussian surface, then the Gaussian surface this is the small surface area on the Gaussian surface, which is ds. Electric field is along this side. E is the electric field. Now when we talk about then E and ds have same angle, because E and ds have same direction, so their angle is 0 degree. So you have E ds cos 0 degree integration, which is equals to 0 by epsilon naught, because q equal to 0 inside the shell. Inside the shell charge is 0. There is no charge inside shell as we are seeing this. So you have E close integration ds equals to 0. Since close integration ds is a surface integration which should not be 0, therefore this means that electric field is equal to 0. Thus electric field inside the charge shell is 0. So here we are writing I and in for inside. This is inside, you are finding inside. So electric field inside the shell is 0. Now let us have the second part. Second part, you are going to find electric field on the surface. So on the surface, so this is capital R radius, and this is the Gaussian surface, small r. So we are taking here a small surface. This is ds. So electric field and ds have the same direction. So this is ds, this is electric field. So our second part is electric field on the surface of charged shell. So second part is electric field on the surface of charged shell. Here you have, according to Gauss's law, close integration E dot ds is equals to q upon epsilon naught. Since we are finding on the surface, so write here S for surface. So here ES surface and S have same direction, so angle is again 0 degree. So you have ES ds cos 0 degree, close integration is equals to q upon epsilon naught. So you have E outside, close integration ds is equals to q upon epsilon naught. Now this is ES and close integration ds of the small part ds on the surface. So when you integrate it, you get the surface area of sphere. Surface area of sphere is 4 pi r square. So right here, this is 4 pi capital R square, which is equals to q upon epsilon naught. So ES is equals to 1 by 4 pi epsilon naught q upon capital R square. Here you have sigma is equals to charge q by 4 pi r square. So we know that sigma is equals to charge q by 4 pi r square. So what you know? You know sigma surface charge density equals to q by 4 pi r square. So you have charge equals to sigma into 4 pi r square. So therefore put it at this place. you get Es is equals to 1 by 4 pi epsilon naught into sigma into 4 pi r square upon r square. R square cancel, 4 pi cancel, you have sigma by epsilon naught. This is Es, which is constant. Thus, you have find what is electric field on the surface of the sphere. Let us find electric field outside the surface of the sphere. This means that we have to take a Gaussian surface here. This radius is r, so the surface become on the upper side, Gaussian surface. So you are going to find electric field outside the charge shell. Electric field outside the charge shell. Here, according to Gauss's law, you have close integration E dot ds is equals to q upon epsilon naught. Now here again E outside ds, you out कर दे रहे हैं, OU to out here, E outside upon ds, E outside dot ds have angle 0 degree. So you have E outside, it is ds cos 0 degree is equals to q upon epsilon naught, close integration. So take out E outside, close integration ds is equals to here, this is q upon epsilon naught. So you have E outside into this close integration ds is of radius r surface. So surface of sphere having radius r, so you have 4 pi small r square, which is q upon epsilon naught. So E outside is equals to 1 by 4 pi epsilon naught q upon small r square. This is equals to electric field due to a point charge. So charge cell behaves as a point charge if you are taking the point outside the charge cell. Now let us have the graph variation of electric field versus distance. Variation of E versus R for charge cell. Here it is the charge cell. This is x-axis, this is y-axis. Let on the y-axis we take electric field and on the x-axis we take distance. So this is the point where small r is equals to capital R, and here small r is, this is inside the shell, this is outside the shell, and this is on the surface of the cell. So you have electric field E inside is equals to 0. Here is the maximum electric field. So electric field will be maximum at this point. And as distance increases, electric field will decreases. So I am writing here this side E inside is equals to 0. Now electric field will vary with distance. As distance increases, electric field will vary because E is proportional to 1 by r square outside the cell, and on this surface here electric field will be maximum. Or here on this surface, this point, this is the maximum electric field. This point electric field E surface is equals to sigma upon epsilon naught, and as it varies, electric field will be a curved line. So you have electric field E outside is proportional to 1 by r square. So this is the graph of electric field. Here you are saying that electric field inside is 0 and electric field on the surface is maximum. Electric field beyond the surface is decreasing with the reciprocal of r. Let us have numerical based on this. Here I am giving you a charge cell. This charge cell have charge Q, which is equals to 1.6 10 to the power minus 7 coulomb. Let the radius of the charge cell r is equals to 12 centimeter. Let us take a distance small r outside from the cell, which is 18 centimeter. Then the question is, what is E inside? what is E on surface or just outside? What is E at outside at distance 18 centimeter. So we are going to find one by one. So number A part, you know that electric field E inside is equals to 0. So electric field inside the charge cell is 0. Number B, electric field on surface is equals to 1 by 4 pi epsilon naught Q upon capital R square. Put the value, the value is 9 into 10 to the power 9 and Q is given 1.6 10 to the power minus 7 and R is 12 centimeter. So you have 12 into 10 to the power minus 2 whole square. So you have 9 into 1.9 into 1.6 into 10 to the power 9 into 10 to the power minus 7 upon 12 into 10 to the power minus 2 10 to the power minus 2. Here eliminate this point, you have 10 on denominator. Now we divide it 12 by 4, so we have 3. 16 by 4 we have 4 divide कीजिए by 12 we have 3 9 here 3 cancel out. So what you have on the numerator side, you have 10 to the power 2 and on denominator side you have minus 2 and plus 1 here. So you have 10 to the power minus 3. So you have 10 to the power 5 Newton per coulomb. So electric field on the surface is 10 to the power 5 Newton per coulomb. Let us find the next part, that is electric field 18 centimeter outside the charge cell. So number C part, electric field E outside is equals to 1 by 4 pi epsilon naught Q upon R square. So this is equals to 9 into 10 to the power 9 and Q is 1.6 10 to the power minus 7. Here R is 18 into 10 to the power minus 2 whole square. So you have 9 into 10 to the power 9 into 1.6 10 to the power minus 7 upon 18 10 to the power minus 2 10 to the power minus 2. Now remove this point, so you have 10 in denominator side. Now divide it, 9 when divided by 18 you have 2 divide by 16 you have 8 here. Now divide it by 2 again, so you have 4 here, divided by 2 you have 9. So you have 4 upon 9 and the power is 10 to the power 5. So divide 4 by 9, so you divide 4 by 9, so give a point here, 0 here, 9, 4 you have 36, again 4 here, so you have 0, so again you have 36. This means that this is 0.444 recurring 10 to the power 5, which you can write 4.44 10 to the power 4 Newton per coulomb. This is the electric field outside the charge cell. Thus you are enjoying physics. Do like, share and subscribe my channel. Thank you.